top right, the word scatterplots. And basically when you have scatterplots, that's when you have graphs of data points that don't fall on a particular line. Or don't fall exactly in a line. And your examples to that would be as such. You have three different options. Let me show you. Here's one, example number two, example number three. If your dots happen to look like this, let's say you're graphing something out, you know, maybe you could make a dot of, you know, maybe you could do like time studying for a test. Time studying in your grade. You know, or this would be like, you spent no time studying, so this was an F, and you spent time studying. All right. If your dots look like they form a pattern that goes uphill like this, it's called a positive correlation. And you're going to ask me how to spell correlation. Two R's.
Two R's.
Or your dots could start high and go downhill. And guess what that's called?
Distance per time.
Negative.
Thank you. Negative.
Distance per time? I mean, that's what it looked like, I think. Yeah.
And it could be, you know, and then obviously the last choice, if your dots are just all over the place.
Why the best fit?
Everything.
Why the best fit?
That looks like my sleep earache.
That's no correlation. No correlation.
This Sean was talking like
Oh, precious.
Now, what Tyler was talking about there is kind of part of a truth sort of thing. You know, when you do all this graphing stuff, they will ask you to try to find what is called that line of best fit, which means you try to somehow split that line so that half the points fall below it, half the points fall above it, and you kind of, it goes right down the middle. This is not an exact science. I mean, you can't, there's no way to get an exact perfect answer or to match up. I mean, you can get close and that's going to be good enough. But the line of best fit is where you sit there and you have those dots and you try to make a line that goes, kind of splits them in half, and sometimes you'll have a dot sticking way out there that throws things off, kind of an outlier that you kind of have to ignore. But I believe you will at some point be able to ask, let me look and see what they ask you to do before I give you that worksheet. Oh, look at page 470. Look at page 470. You looking there?
yeah.
See the data in that table.
Yes.
It says to make a scatter plot from the data in the table. Then draw a trend line, which is that line of best fit. And then it says write an equation for the trend line. How would you write an equation from a scatter plot? Well, here's the gist.
In a way. I like the thing.
It is a nice color. So you've got x is 1. Here's your x line. Here's your y line. X is 1. I should probably, and y. Wait, what do all my things do here? They keep going up to 85. How in the world do we do that? I'm gonna have to change my
And what is
1,
this?
2, 3, 4, 5, 6, 7, 8, 9, 10. What am I gonna do my top by? In order to get 85 on there, probably by 5. So 5
15.
for 10s? Maybe I should do 10s.
15.
10, 20, 30, 40, 50, 60, 70, 80. 30, 40, 50.
Go up to 90 because 85.
I will get 90 right there. So then again, this would not be Carter Westfall. You're not freelancing this. You will use actual graph paper or something because this needs to be as exact as you can. 114 goes right about here. What's my next one? 227 goes right about here. 343, 343, 453. Oh look, we do get some sort of a magic kind of 53. 570. 1, 2, 4, 5, 70. And 685. 685. So you've got these points here. And you are trying to, first of all, make, they call the trend line the line of best fit. But the problem is going to be when we have to write this equation. What do you think? Does that look okay?
Yeah, it looks perfect.
Oh, look at that. Who said that? That was nice.
It's beautiful.
So, if you're looking for the equation, remember, you've got y equals mx plus b. There's not going to be, I mean, there will be a wrong answer if you're way out of the ballpark, but really, you've got kind of, you just have to look at the line and figure out. First of all, it looks like it goes through the origin, so I can put plus 0 there. The question is, what's really important here is how do I figure out my slope?
You don't.
Well, you do. You see the slope there. You've got the point. Well, first of all, you could use the slope formula. Look, we've got this. We got point 114, and I've got point 227. You can almost look at it and see. Remember, slope would be what you multiply this by to get to this. You can come awful close to that. Or you could do the slope thing, which is y1 minus, or y2 minus y1 over x2 minus x1, which you end up with what? 27 minus 14 is 13 over 1. So there's your slope right there. Y is going to equal 13x. Now, is that exact?
No.
No, because if you use two other points, it probably doesn't work out as well. If you use the point 343 and 453, what's your slope going to be?
Higher. Maybe.
We'll do the math. Subtract the y's. What's 53 minus 43? 10.
10.
4 minus 3 is 1. So in this case, you actually get your slope to be 10. So that's why getting close would be good. Now, if you put a negative slope on there, you get it wrong. If you put like -2, whatever, that would be wrong. But there is not specific exact things. I mean, you would be able to challenge anybody in saying, well, this is what I got and this is why I got it. So just go into this knowing that if you're a perfectionist, which actually none of you really are, most of you don't perfect anything in any way, shape, or form. But
I prefer some video games.
wait, why is it?